Hi, I'm Guang, 15 years old, secondary 3 for NS High School. In this lesson, we'll finish what we started in the previous lesson of techniques of definite integration. So what exactly did we have in the previous lesson? So we had this cardioid, r is equal to 1 plus cosine theta. So this cardioid, in the last lesson, we just find its perimeter and its area. Alright, so you might be wondering what else is there that we could find. So in this lesson, we would be trying to find the revolving volume about the x-axis. Well, for this revolving volume about x-axis, that means you have your heart shaped and it's going to spin to make a volume. Alright, so now let's think about how can we find its revolving volume about x-axis. So normally, how would you find the revolving volume? So generally, you would have, let's say, we have this graph over here. So you would have, let's say, A and B. You would have pi r square, which this case you have, like, let's say FA, which is y is equal to fx, of course. So this height here will be FA. So at this moment, or at this point, it would be pi FA squared, alright? But for that pi r square, you would add from point A all the way to point B, alright? So that is how you would be finding its revolving volume, alright? So since you would be taking them disk by disk, alright? So that is how we are going to find the revolving volume. But now for this cardioid, how are we going to find it? Right, so for this cardioid that we will have, let's first try to find its parametric equations, since this here is in polar coordinates. So how do we find its parametric equations? Now x is equal to r cosine theta. So r cosine theta, you can sub r inside to get cosine theta plus cosine square theta. And y would be r sine theta. Well, you could put that in and get sine theta plus sine theta cosine theta. Alright, well, so what if we have these two parts? Now, we want pi r square. So that means for each disk, this volume, we would have integrate along something pi. So r in this case would be y. So y squared. And then you need to times, of course, the width of your disk, which is dx. That means you will need to find dx, which means we need dx. So here will be a d theta, which you'll have negative sine theta minus chain rule. So 2 sine theta cosine theta d theta. Right, so this is what you're going to have when you change dx. So y, you'll be changed to this, dx, you have this part over here. So we are going to have pi, now y square and then dx square. So I'm just going to erase this graph over here. So squared and then dx. Alright, but what are the boundaries? So now let's think about it. Here we have from x So originally it is dx. So since originally it was dx, that means this disk by disk is actually in the positive x-axis. So in order to make this part also in the same direction, we actually need pi to 0. Alright? So this boundary will be from pi to 0. Beware, not 0 to pi, not pi to negative pi. You're only using a radius, not the entire diameter. So this is what you are going to see. Alright. So next up, pi, then we could kind of like, so here's a negative that you could use to invert these two, invert the boundaries, and then you could also take out a bunch of signs, I guess. So here you would have sine cube theta d theta. Now of course you can expand this part. So when you expand this part over here, there will be 1 plus 2 cosine theta plus cosine cube d theta. And what would you get from that? So 1, then you have 2 cosine theta, which will have 4 cosine theta, and then you have a squared term, which is 5 cosine square theta, and then the cube term, which is 2 cosine cube theta. So here you have sine cube theta d theta. Right. So these are just the terms that we will have to look at. Now, for each of these terms, what do we have to do? Now for the first term, sine cube theta d theta. For the second term, so the 4 is taken out, that means you just have cosine theta sine cube theta d theta. Then for your third term, 5 pi, then cosine square theta sine cube theta d theta. And of course, last but not least, 2 pi cosine cube theta sine cube theta d theta. Alright, now how do we plan on solving each of these? Now if you realized, we could actually for each of them put the sign into the d theta for each of them. Yep, for each. So how would that work? That means you would have cosine here, but of course you have to change the front part to a negative. And then for the rest of the signs, which for each, again, you have sine squared, which is 1 minus cosine squared. So that is what you are going to have in order to solve this part. Now let's look at the first term, where you will have pi. So sine cube theta, we put 1 in, we get a negative with the d cosine theta. While inside it is 1 minus cosine square theta. Alright, so this is what the first term will look like. Now for the second term, again a negative. For pi, integrate from 0 to pi. So here instead you have cosine theta 1 minus cosine square theta, then d cosine theta. And then you'll have minus 5 pi, integrate 0 to pi cosine square theta, 1 minus cosine square theta d cosine theta, and then minus 2 pi, integrate from 0 to pi cosine cube theta, 1 minus cosine square theta d cosine theta. Right. So, to solve these, the first term here is obviously cosine. So you can choose to just write everything out again. So cosine theta, and then for the part behind, you're going to have minus 1 over 3 cosine theta, and then you have 0 to sub in 0 and pi. Now for the second term, minus 4 pi, and here you will have, oops, there's a cube here. So half cosine square theta, and then minus, so this is a cube which becomes a 1 over 4. Minus 5 pi, and then so square, which becomes 1 over 3 cosine cube theta, then minus, so to the power of 4, that means 1 over 5, and then to the power of 5. And for your last term, which you will have 1 over 4 cosine to the power of 4, and then minus 1 over 6 cosine to the power of 6 theta. Right, so how do we find all of these terms together? So for your first term, cosine pi, which is a negative 1 minus 1, so you have 2 here. So 2 minus 2 over 3, which this first part will give you, so I'm going to just write that up here. So this first part, from negative 1, negative 2, so with this extra negative in front, you will be seeing 4 over 3 pi for your first term. Then the second term, what's so special about it? Although you have a negative 1, but since this is squared, that means both are positive, which means they cancel out. So that means this entire term is actually a 0. So you don't need to consider about that anymore. It's just 0. Now this third term, you will have negative 1 minus 1, which here you will have a negative 2 over 3. So negative 2 over 3, you will need to add on 2 over 5. So 5, if you put it inside, that means it is negative 10 over 3. Then you have to minus, or since it's negative, so it becomes add on 2. Alright? So that means again, you also get 4 over 3 pi. Well, for your last term, it is the same thing. Since this is the power is even, that means it's a 1 and a 1, which they minus and cancel each other out. So here you have 8 over 3 pi. Alright? So this is your revolving volume of this cardioid about the x-axis. Beware, this is just about the x-axis. If you want to revolve around y-axis, then that's a completely different story. Now, did you guys have any questions during this process? Since it might be kind of weird to use this method, isn't it? since you might be wondering, since this is a cardioid, that means you have the two, should I say, heads of the heart. So they're pretty round and they kind of have a dent in the middle, right? But if you just use this, doesn't it include the dent and count it again? Well, actually, since you have to be aware that this is in the x direction, right? So when you're integrating in the x direction and you start from pi to 0, while the rest of your cardioid is actually in the x direction, since you have keep adding on, but the front part, it is actually going backwards. So since it's actually going backwards, it actually becomes minus, alright? So it becomes a negative. Well, you can go and try it on your own. Like, you just have the top part, you can try to find, well, it kind of just changes and starts moving backwards. Well, for that, you only need to find when the first derivative of this curve is infinity, since it is a straight line down in order to go backwards. So to turn back. Now, since it turns back, when it becomes negative, that means it's actually deducted in the entire process of calculating. Alright, so there's one interesting part when you try to calculate this revolving volume, since at first it might seem quite weird, or you might not understand why can't you just do that. But after you realize the direction of what you're finding, since you have two different directions, that means you would be able to quickly understand why one part is actually negative while the other part is positive. Alright? So I hope for this lesson you're pretty clear of it so far. I'm just going to do another quick summarize of what methods are pretty much used here. So firstly, you'll want to change from your polar coordinates into a set of parametric equations, which is shown over here, your x and your y. So these are your parametric equations. Now, with these parametric equations, you could use the normal way to find your revolving volume. Now, to find this revolving volume, you realize you need a dx, which then you will take one part of the parametric equation in order to find how you can convert dx, so that everything here becomes as a term of, in terms of theta. And then of course you just expand it, and then you do some trigonometric configuration, manipulation, or whatever you like to call it. And one important thing used here, if you realize, is your identity, where sine square plus cosine square is equal to 1. It's used a lot here. And then it is your basic algebraic integration. Alright? But of course, you can also use other methods. Like, let's say for example, hey, you want to change this into double angle formula, you want to change that into double angle. Well, it's really up to you, but it just depends on which way you prefer to solve it. Alright? But of course, you have to be very, very aware of the boundaries of how you're calculating it. Now, if you have watched the last lesson, you might be, again, confused. Why can the last lesson, it seems to go backwards? But in this here, you actually need to go forwards. Well, that's because you have to think about what kind of system are you using, which coordinate system. In this case, since you start with your Cartesian coordinates, that means you have to follow whatever that's in your Cartesian coordinates in order to determine what is your boundary of your polar coordinates. Or in the last lesson, it is only polar coordinates. So that is why you can go in the direction of your theta. Alright? So I hope that you are clear of everything so far. I'll end this lesson here, and thank you for your watching.